don't have many slides. I think I can finish on time. So, okay. When people look into this topic, Android on edge, I think two questions will come into your mind. The first one, does Intel's working on Android? So when I come into to the meeting, so I have meeting someone not here now. So he asked me, does Android on Intel? I think Android is on ARM only. So that's not true. So when I started joining Intel, we're already working on this Android. We're working on Android like 10 years. It's some up and down. So we working on mobile. So we don't have mobile roadmap, but we do invest a lot on Android. If maybe you guys know, on last 3 Google I/O. We work with Volvo and Google to show the Android car in the Google I/O demo. So it's last 3 years, you can see it. So we're working on quite a lot on Android. So the second question is, what Android is something? I believe Android is only for device. Why is coming to edge? So this is something I want to address today. Okay. Let's skip this most important part. This data is not coming from me. It's coming from the this year's Google I/O keynotes. So currently we have 2.5 billion Android device. That majorly means every 3 people in this earth, in this world, have at least one Android device. That's a pretty big one. That's why the Android is becoming the most important OS in the world now. And it's not only for device, it's also for most of the other things that's coming to my mind, to your words. Yes, that's why I want to talk. Android is not only for smartphone. It can be into many other scenario for you guys. I know you guys most of it working on edge cloud things. You may don't know the Android, but you should know all the use case here. So like retail, cloud gaming, digital signage, automotive. So all these things is something Android can working on. Maybe you will have this question that, okay, why Android can working on this world? I think in my mind, the most 2 things for Android, the advantage for Android. One is the largest ecosystem. So if you see now, it's quite easy to get the Android app developer. It's quite easy because many people, it's too many Android applications in the world now. So it's quite easy to get it. And also, Android is open source interaction OS in the world. So if you have any use case want to interaction with Android is a good one for you. Go into the detail. For the retail, there's many things like personal shopping experience, a smart retail use case here. So actually we were working with JD.com before. So we built the Android-based smart retailer use case. For automotive, I mentioned before. So there's we working with Volvo and all other vendors to working on the Android on automotive. So also for the smart city, there's also very many interaction between the UI applications there, so we can use Android into that. And most important case here is the cloud gaming. So when last year when Google announced the Google Stadia, there's many use cases using on the cloud gaming world. So definitely, here's many use cases on, but when for Android, there's many applications also on Android. So when you apply it into Android, it can be have a better work the stacks for that. Okay, any questions so far? I know Ms. Guys, I know Android is maybe a little bit far from you guys, but I want to hear some feedback from you about the use case here. Anything? Okay, good. Okay, so as I mentioned, we can cross many use cases using Android on many edge use cases. So how we can do that? So firstly, definitely I mentioned before, there's 2 million Android applications in the world now. So it's when you think about the use case, it's very to use it Android application into your world to make it your work more easier. And also in edge case, it's most of them is using Linux market. It's much larger than Android. But when we want to move it together, bring it together, we use the workload consolidation methodology to running Android into Linux world. It will make things much easier to use all the Android application into your case. And that's why we see a lot of the increased demanding for Android to use experimental Android VM and unit container use case. And then that one will create unique opportunity for us to create more user experience for the user. Okay. Then what's the solution from Intel to answer this? That's we call Celadon as a service. Firstly, what's the Celadon it is? So Celadon is a Android open source platform for Intel architecture. So how we can do that? We use because we have a strong relationship with Google, so we can use we have early access about Android release, so we can deliver latest Android on Intel platform. We can deliver when we give it to you, it should be the latest Android with the best support on Intel platform. Like what we do for Android 10, since we use after Google published Android 10 release, we only use 40 hours to publish our own Android 10 solutions. Then we unitize all the integrate all the Intel's hardware accelerator into our solutions. So make sure all the Intel's platform accelerator like Movides, all CPUs can be working perfectly on our with our Celadon code base. Then we shift all the solutions from all the edge use case based on your needs, like retail, automotive, smart home, everything you can see. So that's a basic Celadon it is, and how the Celadon service is working. Firstly, it's fully open sourced through Celadon, and we use low cost, high scale solution to serve all the OEM, ODM, and long tail users. Why we mention long tail users? I think maybe you guys don't know because so for Android we have to support multi update for Android to make sure you can running the latest Android on your device. So how we can support the user which used it like 5 years ago Silicon? So we want to use this way to serve the long tail users. And also we want to the simplified way use one code with one long target, one image for all Intel platform, and all service mode, like environmental VM and containers. So this word should be very familiar with you guys. So yeah, and also we are fully compliant with we are fully Google compliance on leading platform. That's a major difference between Celadon and other open source project, Android project. If you want to running Google service, and even if you want to call it yourself it Android, you must have to pass the CDD and CTS 100%. So we create this stack and pass the CTS and CDD based on our leading platform. Then you can have a very good reference for you to pass it on your product. That will be very confident for you. Then how we can do that? If you see the middle of the framework, that's a environmental word. Basically, the environmental hardware, Intel's hardware, and we have bootloader, Android bootloader, and running the kernel driver, HAL, and Android application there. So that's a simple thing. And the most important here is we call AAF, Auto Adaptation Framework. This framework will get you to automatically to choose right driver and HAL for you to running on your platform. That's a major reason how we can use one image to support all the hardware and different VM and even containers. So like in the picture in your left. Yeah, so that one is in VM. So we use when we have our one image into the VM environment, we also use the auto AAF to detect what kind of HAL we have, what kind of driver hardware we support in the VM environment, and to automatically detect which driver, which HAL we can load, we can use. And also in the container environment, we do the same thing. So when we're running into container, we will use automatic deploy to check what kind of hardware we have and how we can support that, and use the right HAL and right driver to support it automatically. So that's a major architecture for Android to running on environmental VM and container to support all the use case here. Yeah. So. Then what's the difference? So I think this one should be very familiar for you guys. Is so when the one workload, the one running on environmental, definitely that will be have a higher resolution, lowest extensibility and lowest density. For VM, it's also have a very good isolation, but maybe density is not so good. But for the container, it should be much easier to do the much better density. Because we share the kernel between the container and the host OS, so it will give less isolation. So this part should be, you guys should be know than me. So I think you will feel the very so we didn't talk about the performance on last slide. The reason is because the performance between these three is quite complex. So we try to address this question. So we try to use this method to use the Antutu benchmark. I think if you know Android, it should be very famous one. So we normalize the Antutu score to bare metal, and you can see when we use the only one instance, that's very straightforward. So bare metal have a similar. Bare metal definitely have a best performance, but when we have a container will be a little bit different, but should be very similar. But when we have VM, it will have more performance downgrade. But when we do the when we have a more instance, but in this picture we will have like 8 instances. So you can see the performance, the VM and container will come to very similar. Yeah. And we don't have the more density, but in theory, when we have much more density, the container will have better performance, because this one we don't. So container will don't have the memory restriction here. So any questions so far? Okay. So we try to make sure this one can be used, can give you the best convince to use that, most easy to use that. How we can do that? Definitely first one, we use one build time for everything. I'm not sure you guys know Android. So currently, because Android have more and more info into the code, so its build time is become longer and longer. So we use one code base, one long target, so you can have one build time to get everything. Also, we try to utilize reduce your effort, so you don't need to build one image for the one interval from like the Apple Lake, and then you don't need to build too many things. You can only have one image to running all the Intel platform, both bare metal and VM. And we are working on to make the container also into this one image, but it's ongoing work. But this is our goal, to make sure we can have one image for everything. And also we have a USB live image support. So that means if you have built the image installed into the USB stick, you can install into any device you have, your laptop, your server, your desktop. Everywhere is okay. So in one words, we try to make sure Android on a just work. It's just work. So that's what we want to get your feedback. So we try to make sure everything is as easy as possible. If you see, we want you guys to try, and if you see anything like, okay, it's not working, or that, please contact us. We were very willing to help you to address these issues. Okay. So this is what we have now. So if you go to our website, you can get the Android containerized Android with Android P is for Intel's architecture. We also have support both all the bare metal VM and container on Android 10 under the project Celadon. So you can get the link, and maybe it's too long. But anyway, so if you go to this link, you can get everything I talked about today. And again, so Celadon is an open source community. So if you want to contribute to our community, please go to this website, and we have the guideline and everything here, so you can contribute into that. Finally, call you guys action. So firstly, learn more to go to that website, and also the project Celadon, and win customers. That's the most important thing. So we want to you guys to try Celadon and decide whether Android on Intel architecture is good for you and for your customer. And also, if you think Android is good for your product for your customer, please think about use Project Celadon for your POC, because it's really easy to use and can be across all the bare metal VM and container use case. And if finally, so join our mailing list to discuss more, and so we can, if you have any question, any concerns, any requests, feature requests, you can just hang out and find us. Okay, that's all from me. I know Android is is not belong to your words, but I really think that because the Android OS itself is really powerful. It can be into anywhere, and also it's open source. So we really think we can talk together to see more use case more than I bring. Okay. Thank you.
Thank you so much for. Thank you.